In this video, we're going to take a closer look at rational functions. Remember, a rational function is one polynomial divided by another polynomial. And functions like that can actually have fairly sophisticated behaviors. Their graphs can look very complicated, much more than polynomials. The denominator of a rational function might be 0 for certain inputs. Now remember, you're never allowed to divide by 0. So that means anything that would make the denominator 0 cannot be plugged into this function. The function will not be defined for inputs that make the denominator 0. However, we don't just stop there by saying we can't plug that number in. We can still talk about the behavior near that point. If the numerator is not 0, then we can still think about the graph of the function, and the result is that we see what's called an asymptote, which is a line that the graph gets really, really close to. That's what happens if you plug in a point where the denominator is 0, but the numerator is not. On the other hand, if the numerator is also 0, you might have an asymptote, or you might just have a hole in the graph. So that's what these two pictures illustrate. On the left, we have a function x squared minus 4x plus 4 divided by x minus 2. If you try to plug a 2 into the denominator, you get 2 minus 2, which is 0. So that means you cannot plug a 2 into this function, because the denominator would be 0, and you can never divide by 0. But if you look at the numerator and you try to plug a 2 into that numerator, it turns out you get 4 minus 8 plus 4, which is also 0. So the numerator and denominator are both 0. And when that happens, sometimes what we see is just a hole in the graph. So it's like we have a function, but with a point missing from the graph, and that's indicated here with this open circle. Now on the right side, I have a different function, 10x squared minus 41x plus 40 divided by 10x minus 20. If I try to plug 2 in to the denominator, I get 10 times 2 minus 20. 20 minus 20 is 0, so I cannot plug a 2 in. That means this function's not defined at x equals 2. But it's a different behavior this time. Instead of just having a hole in the graph, you actually have the graph getting closer and closer to this vertical line. So the dashed blue vertical line here is not part of the graph, but it's helping to show the behavior of the graph. On the left side, the graph of the function gets closer and closer to that line. And on the right side, it also gets closer and closer to that line. It just happens that it goes up on one side and down on the other. So how could we tell that there was an asymptote here? Well, when we plug in 2 to the numerator, you don't get 0. You actually get negative 2. So the numerator is not 0, the denominator is 0. That's a sign of an asymptote on the graph. So let's be clear about our terminology. An asymptote is a line that the function's graph hugs. The graph of the function gets closer and closer to this line, but the line is not itself part of the graph. It's not showing the actual function values. Vertical asymptotes occur sometimes when the denominator is 0, like in this example we already looked at. You can also have horizontal asymptotes. So vertical and horizontal here just refer to the line. In this case, this is a vertical line that the graph is hugging, so that's called a vertical asymptote. A horizontal asymptote would be a horizontal line that the graph hugs, like we see in this picture. So this function, x squared over 4x minus 4, it has 2 vertical asymptotes. We can see that the function's hugging those vertical lines in these various places. And it also has a horizontal asymptote. This horizontal line that the function's graph hugs. And we can see from this graph that the horizontal line appears to be occurring at the value 1/4. Now, we were able to figure out the vertical asymptotes by asking when is the denominator 0. But we still have to discuss how we can figure out the horizontal asymptotes. If the numerator has a smaller degree than the denominator, that is, if the denominator has a larger degree, then there'll be a horizontal asymptote on the horizontal line y = 0. If the numerator has a larger degree, then there's no horizontal asymptote. And if the numerator and denominator have the same degree, then what you actually do is you look at the leading coefficients. The leading coefficient for the numerator divided by the leading coefficient from the denominator. And that tells you the horizontal asymptote. So here are 3 examples. The first example, x squared over 4x cubed minus 4. That has a larger degree in the denominator. 3 is bigger than 2. Whenever the denominator has a larger degree, then there's a horizontal asymptote y = 0. And that's what you can see here, a dashed line at height 0. The second example, x cubed over 4x cubed minus 4. Sorry, that's actually over x squared minus 4. Now the numerator has a larger degree. When it has a larger degree in the numerator, there's no horizontal asymptote. And we can see in this picture there's no horizontal asymptote. The graph's not getting closer to any horizontal lines here. For example, this keeps going up, this keeps going down. Now, the last graph we see, x squared over 4x squared minus 4, the numerator and denominator have the same degree. So in order to figure out that horizontal asymptote, you take the leading coefficients. The numerator has a leading coefficient of 1. The denominator has a leading coefficient of 4. And so leading coefficient of the numerator divided by leading coefficient of the denominator is 1/4. That's how we get this height 1/4.